Alright guys, it's finally time for us to talk about the Steam Deck. Just this past week, Valve announced to the world their newest addition to the mobile PC gaming lineup, and you guys have been asking me a bunch of questions over on Discord, mainly, will this device be able to play AAA games at pretty decent performance? And overall, is this type of device going to translate into a good mobile gaming experience? And more critical for me, of course, is are we all just becoming some console peasants? Well, unfortunately, the answer is yes to all those questions, but before we come to that conclusion, let's dive a little bit deeper. Hey guys, Turk here. I hope y'all are having a great day. Man, I love talking hardware development with you guys. We have talked extensively about the PlayStation 5 and the Xbox Series X, and we've even dove pretty deep into the technologies that's included with the RDNA 2 graphics cards. But just as I said in the intro, Valve has thrown us a huge curveball when it comes to next generation hardware, and they're going to be pushing the limit with their Steam Deck in both the performance realm as well as the form factor realm. Now, unfortunately, there's all sorts of videos here on the internet.com, and they just don't do a really good job of actually communicating and telling you guys what kind of performance we're going to expect. So to answer the 3 questions from the intro, we're going to be doing a whole bunch of technical analysis in order to prove that the Steam Deck is actually going to be a pretty decent gaming device. But before we go into those experiments, let's actually cover some of the high-level hardware specifications that we have at our disposal. Now, we don't usually cover consoles here on the channel, so I'm going to post a link down below in the description so that way you can learn about the Joy-Cons, the trackpads, the Wi-Fi connections, and all that stuff, because to me, that kind of tech is just not that exciting. And what I find most important is the CPU, GPU, the storage, the memory, as well as the screen. And fortunately for us, the Steam Deck is pushing the limit in pretty much all of those categories with this little product. Now for the CPU as well as the GPU, Valve is getting their processor from AMD, and it's going to be an accelerated processing unit or an APU. That's a type of device that combines both the CPU and the GPU into a single chip in order to reduce the complexity of the device as well as hopefully reduce on the power consumption. Now from the CPU perspective, we are going to getting a little bit older of a core. It's going to be based on the Zen 2 architectures, kind of like some of the older consoles. But that's where I think some of the comparisons to the consoles fall apart. You know, people have been explaining that it's kind of a chopped down PlayStation 5, and there's other people that have been mentioning it's kind of like, you know, a desktop APU. But in fact, if you dive into the specs a little bit, this tiny processor has more alike with ultra thin and light laptops. As I mentioned before, the CPU component of this processor is going to be packed with 4 cores and 8 threads of the Zen 2 architecture, and it's going to be clocked in at 2.4 to 3.5 gigahertz. This is very similar to the AMD Ryzen 3 5300U, one of their more recent APU designs. Now again, this is coming from their ultra thin and light processor lineup, which is spec'd at a 15 watts, but also sports 4 cores and 8 threads with a maximum boost clock of 3.8 gigahertz. And of course, since this is a mobile or laptop type of processor, it's going to be able to support both DDR4 as well as low power DDR4, which we'll be talking about here in just a moment. Now, the other half of this APU is going to be based on the RDNA 2 graphics core, which is packed in with all of the latest graphics cards, but it's only going to have access to 8 compute units and is going to be clocked at a pretty meager, 1.0 to 1.6 gigahertz. So this is definitely a lighter end processor compared to some of the more gaming-centric gaming consoles out there. However, as we've tested with our 5700G, when it comes to, lighter end games or even running at lower resolutions, 8 cores is actually not a bad solution. And with the updated graphics core, we should see some pretty good performance as well as improved efficiency in this little bitty package. Now, we talked about memory just a moment ago, and then with the Steam Deck, they're going to have access to the LPDDR5 spec. Now, this is going to be included in a lot of the more cutting edge, cell phones, mobile devices, laptops, as well as even some automotive applications. And I've even seen some articles out there that compare LPDDR5's bandwidth and performance to more of those GDDR6 modules that we're more familiar with on graphics cards. For the Steam Deck, it's going to have 16 gigabytes of LPDDR5 on board, and it's going to be clocking in at a 5500 megatransfers per second in a quad channel configuration. Now, this is a pretty stark deviation from some of our more, desktop-based comparisons that we've done, but again, it's going to be a very fast interface and allowing for much higher amounts of bandwidth that's going to be able to feed our graphics solution, which, as we'll see going through the video, is going to be pivotal when it comes to performance of the Steam Deck. Now, the storage solutions aren't all that interesting in my opinion, but if you're going to go with the base level Steam Deck, you're going to get access to 64 gigs of eMMC storage, which, let's be honest guys, that might be like 1 or 2 games on your device. So I highly recommend y'all go with either the mid-tier or the top-tier Steam Deck options, which is going to have 256 gigabytes of NVMe storage, or for the higher end, 512 gigabytes of NVMe storage. Now this is a full spec NVMe storage running PCI Gen 3 at by 4 widths, which is pretty standard on the desktop platform. However, the form factor of those drives is going to be the 2230 spec, which is those little bitty drives that kind of look like one of those Wi-Fi modules. In fact, if you're going to be brave and probably void your warranty, it says it might be removable, but again, those little bitty drives, they don't have really high capacities just yet, so you might be able to get a 1 terabyte drive in there, but for my purposes, I'm just going to stick to the 512 gigabyte version and then swap any types of games onto the little micro SD card that's built into the package. Now lastly, and what I think is the saving grace for the Steam Deck, is the choice of using a 7-inch IPS panel that's going to have a resolution of 1280 by 800. Now for us desktop gaming PC people, 1080p is the de facto standard, and anything below that is kind of, riffraff for all the other gamers out there. However, if you look at some of the other mobile devices out there, I'm looking at you, Switch, they're running at 720p screens. So I really do think this is a great compromise when it comes to visual quality, visual fidelity, and balancing the power and the performance that the rest of the device is going to be able to provide. And like I said, this is 1280 by 800, so the aspect ratio is 16 by 10, but for all the data we're going to be showing in today's video, it's going to be showing 720p data, so the performance is going to be a little bit worse than what I'll be showing today, but I think it's still going to be in the same ballpark. So having looked at the entire spec sheet and carefully inspected each of the selections and put them into perspective, the big elephant in the room here, guys, is will 8 compute units of RDNA 2 running at 15 watts be able to deliver any sort of playable frame rates in any type of games that are out there? Now, before I go and do a whole bunch of experiments, I wanted to see if there was a way we could kind of guess just how well this particular graphics solution is going to perform. Now, if you guys have watched any of my graphics card technology playlist videos, I've got plenty of tools at my disposal, and for today's video, we're going to be looking at the RDNA 2 performance per watt prediction model. Now, we've covered this model in several different videos, and we have made iterative improvements towards the model as time has gone on. And now that we actually have several different AMD RDNA 2 graphics cards to talk about, I can actually start to pump in actual figures into the model in order to guess and estimate what these lower end models are going to do. Now, in order to do that, I'm going to be using Hardware Unbocked's RTX 3080 Ti video and pumping in the data for the 6800 XT, 6900 XT, and all the other RDNA 2 models, as well as the 5700 XT and the Vega 64. Now, you might be curious why I'm including these other two graphics cards, because again, if you go back and check out my older videos, there's several AMD white papers that explain, the jump from RDNA 1 to RDNA 2, but they also explain the jump from the Vega architecture up to RDNA 1. So we're going to be able to kind of, reverse engineer some of these performance and power numbers in order to extrapolate it to the lower power models. Now here in the orange line, this is our original performance prediction model based on the Vega 64 compared to the 6900 XT. When you compare the normalized performance of the 6900 XT compared to the normalized power of the 6900 XT, we actually do see a very sizable performance improvement at 300 watts. And the blue line here is actually combining in all of our actual gaming data from the 6700 XT, 6800 XT, 6900 XT, and heck, I even included a 6800M into the mix in order to see if we could get a better fit when it comes to the slope of our line. And sure enough, as we plug in a trend line into this data, we do in fact see a better correlation compared to our original model. And fortunately for us, as we start to go down the slope down to 15 watts, we do expect to get, roughly 40 FPS as our average frame rate across all different games. But do keep in mind, this is 1080p data. This is not 720p data. So we're even going to get even better FPS with our lower wattage model. But I also included our Vega 8 APU because as you'll see in a lot of our charts today, this little bitty APU is actually able to do some pretty decent 720p gaming and actually reinforces the performance that we would hope to expect at this particular power level. Now that we have a decent understanding of just how much potential there is with this little iGPU for the Steam Deck, it's time to put the specs to the test and see just how these improvements translate into real gameplay. Now, I don't have access to this specific processor, but each of these specs is pretty easily testable, and we're going to be able to confirm that as we increase the specification, we do in fact see improvements to frame rate, and that should hopefully translate into the final product for the Steam Deck. Now again, I don't have access to this specific CPU, but I believe the 5700G that we've reviewed here on the channel is going to be a decent analog for our experiments. We're going to be modifying the core count, the core frequency, as well as the iGPU clock, and I think more importantly, the data rate. We're going to be changing all these variables and seeing how improving the spec actually goes and improves our gameplay performance. Now lastly, I've recorded a bunch of different gameplay clips at 720p, and we're going to be going through a little bit of experiment to see if you guys can tell the difference between, a 720p gaming experience and a 1080p gaming experience. Now with that said, let's get to the first test. Now the first specification we're going to be taking a look at today, and probably the most critical, is going to be the memory data rate. Now I don't have any LPDDR5 to test today, but I do have a pretty quick kit of DDR4 at my disposal. Now word on the street that LPDDR5 has some significantly better bandwidth numbers when compared to the desktop DDR4 modules. So my goal here is to see if we go from a modest DDR4 level to a pretty extreme level of DDR4 and just see what kind of frame rate improvements we should see. Now the games we're going to be looking at today are GTA 5, Hitman 3, Shadow of the Tomb Raider, Dirt 5, Godfall, and Metro Exodus. If you saw our 29-kit DDR4 comparison video, we should be expecting to see some pretty sizable FPS gains as we increase our data rates. And sure enough, as we go from the green bar there at DDR4 3200 all the way up to the orange bar or the red bar there at DDR4 4200, in many games we almost see double-digit improvements. GTA 5 sees right about 9 FPS, Hitman 3 sees a 4 FPS improvement, and then going down the stack we start to see slightly lower numbers. However, if we take a look at the average FPS from all of the different games, DDR4 3200 there at the bottom, we average right at 49 FPS, and we get a 3 FPS improvement going up to DDR4 3600. That's an impressive 6.1% improvement just by increasing the data rate alone. Now going even further up to DDR4 4200, we gain an additional 3 FPS, which is an additional 5.8% on the performance improvement. Now overall, by increasing our data rate by 1000 mega transitions per second, we're able to increase our frame rate by 6 FPS. Now with any luck, this trend will continue as we go up to the LPDDR5. We might even be able to see values of 60 FPS or even higher depending on the type of game. Now of course that's a pretty broad speculation on my part, but we do prove that in fact as we increase our data rate we are able to get pretty sizable gains when it comes to FPS alone. Now, of course, the next specification we're going to look at is going to be the CPU's core count as well as the core frequency. Now, if you watched our 8-core versus 6-core video from last week, sure enough, guys, for most gamers on desktops, 6 cores performs just as good as 8 cores at most different resolutions in games, as well as with different types of graphics cards. And as we go to 4 cores with this lower power model, I've even done a video where we looked at Shadow of the Tomb Raider in some power constrained situations. And in fact, the CPU shouldn't really care what frequency or core count it's running at because we're going to be GPU limited anyways. So hopefully in today's test, we're going to be looking at, the 8-core performance, the 4-core performance, and we're even going to run at a, all cores overclocked to 3.5 gigahertz and see just how the games perform. Now the games we're testing here are GTA 5, Hitman 3, and Shadow of the Tomb Raider in order to kind of expedite the testing process. But sure enough, guys, even with our stock settings for our CPU, we are able to get 66, 54, and 46 FPS respectively for each of the games. And even cutting the core count in half and downclocking our 5700G all the way to 3.5 gigahertz, the frame rate is actually not impacted at all, and in fact, all of our tests here today are within the margin of error of one another. So in order to save power, I really think that Valve did an excellent job of picking the Zen 2 based architectures instead of Zen 3 because they really don't need the IPC performance with this particular type of graphics solution. So since our gameplay doesn't care if we're running at 3.5 GHz or is only running on 4 cores, what happens when we change our GPU's clock speed? So keep in mind guys, this is all being tested on my Vega 8 iGPU, so the frequency comparisons aren't directly comparable to the RDNA 2 solution. However, we should still see some frequency sensitivity when it comes to the Steamdeck. Now here we're testing the same games as before, but the gray bar here is our stock operation with the 5700G. Now we do see some pretty decent performance at 720p with all of these different settings, but as we go to 1.6 GHz, we do in fact drop between 3 and 6 FPS across the board. Now fortunately guys, I don't think this FPS loss is as critical as we might think. Let's keep in mind that this is the Vega 8 architecture that we're talking about, and the RDNA 2 architecture that AMD has produced is actually much more efficient when it comes to both power and performance, and I don't believe that this frequency drop is going to be as significant as we're seeing here. However, I do want to highlight that the reduction in frequency could in fact impact our frame rates when it comes to the different games today. Now, fortunately though, I also included in here 2.3 GHz, and we do in fact see some pretty sizable gains in the frame rate, and we're going to be using that configuration for our 720p gameplay going forward. Now that we've taken a closer look at each of the specifications in detail, it's pretty safe to say that as these specifications improve, our Steam Deck's performance should be on par with a pretty decent 720p gaming experience. So now it's time to tackle the question as if this type of gameplay is going to be a good experience on the Steam Deck. Now, I'm going to do something a little bit unorthodox when it comes to here on YouTube, and I've actually recorded a bunch of different games at 720p, and I'm going to be presenting it to you without any sort of upscaling or render resolution changes in order to give you guys a native resolution 1:1. Now, I've got a little bit of an experiment for you guys to run. If you're looking at this on a TV or a laptop or desktop monitor, I want you to find a tape measure and measure, about 7 inches or so. Get a ruler or any kind of device like that. And I want you to take the gameplay, I'll put a little highlight here on the screen, and cover and move your screen away or towards you in order to get the screen size to be roughly 7 inches. That way you can kind of see how a native 720p screen would look like. Now, if you're looking at this on a mobile device, I highly recommend you don't do that because you're going to end up like crossing your eyes, and I don't want to be liable for any physical damage that comes to you. But I think this experiment is going to be pretty useful for you guys, so let me know down below if it works out for you and if it actually helped change your mind when it comes to 720p gameplay. With that out of the way, guys, I'm going to be cycling through some clips from the different gameplays as we talk through some of the frame rate charts. Now here we've got our Ryzen 7 5700G running at 4 cores at 3.5 GHz, just like the Steam Deck's going to be running, and we're going to be running 13 different games that are running at, medium-ish detail settings. Settings that are going to be pretty similar to a console experience. Now the iGPU has been overclocked to 2.3 GHz here, and we are running at our maximum memory data rate of DDR4 at 4200. Again, all of this gameplay is at 720p, which isn't exactly the 800p that the Steam Deck's going to be showing, but I think it's pretty analogous going forward. Now, GTA 5 is able to get an impressive 73 FPS, and this is using detail settings that are actually the exact same I use for my standard graphics cards reviews. Now, Doom Eternal is able to get an impressive 56 FPS, which just shows how powerful the Vulkan API can be. Now, Hitman 3 and Necromunda Hired Gun get right at 54 and 53 FPS respectively, so I expect both of these games to get above 60 FPS with the Steam Deck. Now, the next 3 games are kind of questionable when it comes to the frame rate, and that's Horizon Zero Dawn, Assassin's Creed Valhalla, as well as Shadow of the Tomb Raider. Now, we are able to get, upper 40s when it comes to the frame rate, so there's a pretty decent chance that if you tweak some of the settings, or maybe the RDNA 2 architecture boosts us up quite a bit, all these games should be in the clear. Now, the remaining games here on this list are going to be pretty questionable when it comes to 60 FPS gameplay. Now, Godfall is going to be running right at around 39 FPS, Dirt 5 again at 39, and then Control, Metro, and Cyberpunk are running right at the mid to lower 30 FPS range. Now, keep in mind though, that some gamers might actually prefer some of these games at 30 FPS. Metro Exodus is a very cinematic game, and Control in certain instances can be very cinematic as well. Of course, that always comes up to users' preference, so we'll of course have to wait till we get our final Steam Deck device in hand in order to do proper performance evaluation. Now you'll notice that there's a couple games on this list that actually might be interesting to you, and that's going to be Necromunda, Hired Gun, and Godfall. Now we've covered FSR or FidelityFX Super Resolution here on the channel, and this type of technology is going to be extremely cool when it comes to these little bitty devices, because FidelityFX Super Resolution is able to render higher frame rates in particular games by utilizing a lower internal render resolution. However, what we saw in our analysis at 1080p is that certain FSR modes are just not all that playable, but I think at 720p on smaller screens at larger distances, things might actually look pretty decent. So I wanted to show you guys the performance improvement we could expect and give you guys kind of a realistic expectation of what that technology is going to be able to do on the Steam Deck. So let's start off with Necromunda Hired Gun first. Now, we already saw some pretty decent performance here right at 53 FPS, and sure enough, as we go up to FSR Ultra Quality mode, we do in fact get to that 60 FPS breakpoint, and to be quite honest guys, in my playing at this particular setting, I didn't find the experience to be all that much different than standard 720p. Now, when it goes to the quality mode, we do gain an additional 10 FPS, but I do believe even at this reduced render resolution, I think the quality mode's just not going to be good enough for most gamers. Now, I will state as a fact, FSR balanced and performance modes are complete garbage, even though we do get 10 FPS performance improvement as we go up the different levels. However, this is a very promising result for the Steam Deck's potential performance improvement, but I want us to temper our expectations and go over to Godfall real quick. Now, Godfall at native resolutions and medium detail settings, we are right at 39 FPS, which could be playable for most gamers, but unfortunately going up to FSR Ultra Quality mode, we only gain an additional 5 FPS, but we do manage to lock in at our 1% lows right at 30 FPS. Now, similar quality issues arise when we go to the quality, balanced, and performance modes, but unfortunately, as we go up the different quality modes, I don't think the performance improvement is worth the trade-off when it comes to our quality gameplay experience. However, like I said, some people are more tolerant when it comes to lower quality levels, so maybe this is a trade-off that could be worth it for you. If you've got any other questions about the FSR's quality versus resolution, I've got a good video up at the top when I covered the RX 580 and the type of performance you should see in a desktop environment. Now again guys, all of these performance numbers I've just listed are not directly comparable to the performance we should expect from the Steam Deck. This is all mainly to illustrate that with our current setup and our current environment, we still get a very playable experience at 720p, and if we get improved performance from the RDNA 2 based Steam Deck, we should be able to get even better performance from our little mobile device. And that begs the question and is ultimately the biggest hurdle when it comes to engineering this device, and that's balancing the performance of the Steam Deck with the power consumption of the Steam Deck. Now, on the spec sheet, this little APU is rated right at between 4 and 15 watts, which unfortunately, if you're going to be playing all of these different games, we are heavily GPU bound in all of these scenarios, so I really don't think it's reasonable to expect much more than 2 hours of runtime on the built-in 40 watt-hour battery. Now, if you're going to be running lighter games, if you're going to be doing any kind of like emulation on this thing, it's entirely possible to get extended battery life out of the Steam Deck. But if you're going to be playing, AA or even some AAA games, I imagine you're going to need to have access to a power bank or access to an AC wall outlet in order to get the full potential out of our device. And let's not even forget that if we go into those like battery saver modes, if we clock everything down to the lower frequency levels, I imagine the gameplay experience is going to be significantly worse and probably not enjoyable to most people. Now, I have really good hopes that AMD is able to, scale all of the performance down to their lower power wattages, and as we've gone through these different experiments today, all of the specs that are listed for the Steam Deck should provide a pretty decent gaming experience. And unfortunately guys, all of these performance numbers, we're just gonna have to wait till we get final production units in our hands for final evaluation testing, and we're probably gonna have to pump out some new content here on the channel on just how to optimize your gaming experience to get the best performance out of your Steam Deck. However guys, that's going to be our Steam Deck video. I hope you all have enjoyed it. I've loved going and digging into all the different specs. So let me know down below if y'all want me to do any additional evaluation, or if you've got any ideas when it comes to delivering this type of content. I thought the screen size experiment was pretty clever on my part. However, let me know down in the comments. Of course, be gentle with me. You guys can always talk to me directly over at Twitter, @TheTurk. And guys, come August 19th, we're going to be coming back into the streaming game. We're going to be streaming live from QuakeCon at home. We've got a LAN party down in Houston that we're going to be going to, so that's going to be a huge fun time. So make sure you hit subscribe down below, hit follow over at twitch.tv/TheTurk. But that's all I've got for you today, guys. I hope you all have a great day. We'll catch you in the next one.